Welcome back. Now we will discuss about subsequence. So the first question is, what are subsequence? So informally speaking, subsequences are sequences which we will form by selecting the elements from the original sequence. So that is, let xn be the original sequence. So it will have elements, say x1, x2, x3, so on. So a subsequence, which we will denote by x dash, will be formed by selecting the elements, randomly. And there is a condition actually. It's not completely random. Say I select x2, x4, x6, x8. So this is one example where I have selected even elements of the original sequence. I can also do with odd elements, So this is another example. Now I can also select elements randomly. I can select first element, then I can select 100th element, then I can select 1000th element. I can select say 1000 and 1001th element, so on. So it can be, in this way also. But the only condition is, suppose you select xkth term, if you select xkth term, then the next term which you are going to select has to be from xk plus 1th onwards. So you are not supposed to select x1, x2 till xkth term, right? Once you select xkth term, the next has to be from xk plus 1th term. So that is the only condition which we impose, right? So having defined what a subsequence is, the next question which one has to ask is why we are interested in studying about subsequence. So now I am going to answer that question, why are we interested in studying about the subsequences? So for that, let me mention a theorem, right? A theorem which is not very difficult to prove. Let x comma d be a metric space. Let xn converges to p in x, then every subsequence of xn converges. Further, it converges to the same limit, that is p. So this is the theorem, that is, whenever in any metric space, whenever a sequence converges to p or sequence converges, then every subsequence of the sequence xn converges, and it converges to the same limit. Now this theorem is very important. It is not very difficult to prove. It is an easy exercise to prove this theorem, but this theorem can be used to show the behavior of some sequences. Like for example, if I take this sequence, say yn 1 minus 1 1 minus 1 1 minus 1, familiar sequence. Now here you see we have two subsequences, y dash, that is 1 1 1. So this subsequence I have formed by selecting odd terms. Then another subsequence we have by selecting even terms. So if you see these two subsequences, the first subsequence converges to 1, whereas the second one converges to minus 1. So what you have in this example is, you have the original sequence yn, and you have two subsequences in such a way that two subsequences are converging to two different limits. Now suppose if yn is convergent, then by this theorem you can say that you will end up with a contradiction. So this yn has to be divergent, right? Using this theorem, we can easily show that this sequence is indeed divergent. Now this example is not showing us or justifying the full power or use of the notion of subsequences, and we will understand the full power of the subsequences when I discuss a problem about the sequence sin n. Right? It turns out that sin n is a divergent sequence, and it is not very easy to show that sin n is a divergent sequence. So in order to show that a sin n is a divergent sequence, we will be using the notion of subsequences. So there you will really understand the use of the subsequences, and also one more naming theorem, which is Bolzano-Weierstrass theorem, which I will be discussing in the next videos, where you will understand the real requirement of subsequences. And also when we deal with the limit superior and limit inferior, there also we will understand the requirement of subsequences. So what we have discussed is about the definition, then the important theorem, and how we have applied that theorem. I have illustrated that theorem using a small example, which as I said is not showing us the full justification of why we have introduced the subsequences. But as I said, when I deal with a problem on why sin n is a divergent sequence, you will understand the use of subsequences. And also when I discuss about Bolzano-Weierstrass theorem, which will be used in major theorems of analysis, you will really understand the power of subsequences. Having said that, hope to see you all in the next video. Thank you.